All right, find the intervals on which f of h of x is concave down. So if I care about concavity, I know its second derivative is concave down when the second derivative is negative. So like all of these questions, they're going to take a couple minutes, but it shouldn't take you a couple minutes to figure out what your plan needs to be. This is kind of nice. They already gave us the first derivative, so at least we only have to take the derivative one more time. So power rule, power rule, power rule, the derivative of the constant is 0. Okay, so similar to increasing, decreasing intervals around critical numbers are the only place it might be changing direction, so that's where it's going to change from increasing to decreasing or decreasing to increasing. Inflection points are when the concavity changes, and inflection points can only occur if they're a point on the graph and they make the second derivative 0 or undefined and the concavity changes. So hopefully this guy factors. Yeah, that looks like that factors, and that is true at these two values. Okay, did you get that far? So 3x equals 3 might be an inflection point. I'm putting the word maybe there, not because that's a real mathematical thing, but because it's not guaranteed to be an inflection point yet. Being equal to the second derivative, making the second derivative 0 is not enough. And same with this one. This one might be an inflection point. But these are the only two places that the concavity might change. So test something like 0 into the second derivative. We would get 0 minus 9, which is negative. When the second derivative is negative, it's concave down. Try something to the right of 4 or 3, like 4. So maybe throw 4 into the second derivative. Now, notice we've got two representations of the second derivative. So you can plug 4 in here if you want to. I think that's a little harder to compute, whether that's positive or negative without a calculator. Plugging it in here is quite a bit easier. Because if I plug in 4 here, it's positive. If I plug in 4 here, it's positive. And a positive times a positive is positive. So just keep that in mind. You can plug, these both say the same thing. This is a little easier to evaluate without a calculator though. Okay, and then maybe -2. That would make this negative, negative. A negative times a negative is positive. When the second derivative is positive, it's concave up. So, not exactly the same type of line chart because it's not showing increasing, decreasing. But just in case you needed this for a later question, concavity is changing here, so we can now say for sure that this is an inflection point. Concavity is changing here, so we can now officially call that an inflection point, in case you were looking for inflection points. But really, we just want to know where it's concave down. So that looks to be between -3/2 and 3. It's the only times it's concave down. But of course, you need to understand why I found the x equals 3 and the x equals -3/2. These are the only two places the concavity might have been changing. I don't have to check the concavity more values here or between here or outside of here. If it was going to change concavity, it would do in those intervals that I tested. Okay. Anything else about that one?